In this lesson, we're going to talk about rotations in plane space, so meaning not on a graph. So we're going to be using a compass and a straight edge to do our rotations. So first thing is, remember that a rotation is a rigid motion, so it means it's going to keep the same shape and same size, and it turns a figure about a fixed point. That fixed point means a point that stays in the same place, which is the center of rotation. So everything will be measured from that center of rotation. The notation that we use for rotations looks like this. So you have a capital R, so reflections are lowercase r, and rotations are going to be capital R. And then the little subscripts here, the point is going to be the center of rotation. So this is going to be the center of rotation. And then this symbol here is called theta. So that's something you may have seen before. You'll see it later in the year when we do trig, but that's just theta, and it's a common symbol. It's like using an X or a Y, but it's a common symbol used for angles. So like a 90-degree turn, a rotation around 90 degrees, we would say, okay, theta equals 90 degrees. So it's just a variable, so no worries. It looks a little bit weird, but it's just a variable. So this is going to be your angle of rotation. And then the other thing we'll have to know is the direction, which will be specified, or we'll know depending on if the angle is positive or negative. And we'll talk about that in a minute. So the next thing here says a rotation is a blank isometry. Remember, isometry is the same thing as a rigid motion, so it keeps the same shape and size. So the blank here is supposed to represent, is it a direct or is it an opposite isometry? So remember, the difference is the orientation of the letters. So if I look at my original here and I just put arrows in alphabetical order, and then I go to the image, so A prime to B prime, B prime to C prime, and just go around in alphabetical order that way. See how the arrows are going in the same direction? So since they go in the same direction, it means that the orientation is the same. So same orientation, so that deals with the order of the letters. So that means that this is a direct isometry. So all rotations will be direct isometries. So information that you need to be able to do a rotation. There's three things that you have to talk about when you're given a rotation, or if you're telling someone to do a rotation, there's always three things that you need. So the three things that you need is you have to know the center of rotation. So the center of rotation, where is every point coming from? You have to know the angle of rotation, which means how many degrees are you going to turn it. And then the last thing you have to know is the direction of the rotation. So which way am I going? Am I going to the right or am I going to the left? So the direction of the rotation. Now, sometimes if you look at the notation here, sometimes it's not going to specify the direction because the angle of rotation can actually tell you if you're going right or left depending on if it's positive or negative. So sometimes the direction won't be specified, but it's a good idea to just get in the habit. Anytime you talk about rotation, talk about the direction as well. So you have your three things that you need. So when we talk about the direction, there's two ways. You can, a rotation can turn clockwise or counterclockwise. And for clockwise, a lot of times you'll just see CW. Counterclockwise, you'll see CCW. But that's really a good habit to get into. Anytime you're talking about rotation, talk about the direction. So if you look, clockwise versus counterclockwise, well, counterclockwise is the opposite direction that the clock moves, where clockwise is the same direction as the clock moves. So if you're not sure, look at the clock in the room. The way that it's moving is clockwise, and counterclockwise is the opposite direction. So when we talk about rotations, what's different is counterclockwise means that the angles are positive. So if I say rotate this object around the origin 90 degrees and I say positive 90, it's assumed that we're talking about it being counterclockwise because positive angles are always going to be counterclockwise. Where if I say rotate negative 90, I'm talking about a clockwise motion. So negative angles. So if it doesn't specify and it gives you a positive angle, you're going to assume that that means counterclockwise. If it gives you a negative and it doesn't mention clockwise or counterclockwise, that you assume means clockwise. So negative is clockwise, positive is going to be counterclockwise. But it's a good habit, again, to not just make the assumption that positive or negative is going to be counterclockwise, clockwise. You want to actually specify that direction. The Regents really wants that extra step stated. So not just say a rotation around the origin 90 degrees. They want to know, okay, 90 degrees clockwise or 90 degrees counterclockwise. So you really want to make sure that you just specify. So then on the next page, I want to talk about some properties. And it's really just talking about those three key things that we need to know about rotations. And the goal of this is to help you get ready to actually do a rotation using a compass and a straight edge in plane space. So some of the properties, we talked about the center of rotation. So where everything is being measured from, that's the center of rotation. So you have the center of rotation. That'll be the same center for the entire rotation, so that won't change. I'm not going to write that as a property, but the center of rotation will not change. However, the center of rotation, if you look, so let's compare A to A prime. See how the center of rotation is the same distance away from those? The center of rotation from B to B prime. So B, I have 3 slashes. B prime, I have 3 slashes. It's the same distance away. Same thing for C and C prime, same distance. So I do want to add that as a property. So one property is that the center of rotation is equidistant, so the same distance from each pre-image and image point. So it's that same distance away. The angle of rotation, so if you look here, the angle of rotation, so if I say from B, so here from B to B prime, B prime's up here. My angle of rotation is a 90-degree angle. If I go from C to C prime, again, you see a 90-degree angle. And then if I go from A to the center to A prime, again, you have another 90-degree angle. So in this case, this is a rotation of 90 degrees counterclockwise, but the angle of rotation will always be the same. So it's going to be the same angle measure for each set of points. So the angle of rotation is the same angle measure for each point. I'm going to say for each set of pre-image and image points. So that's going to be important. So that's really the process that we're going to go through. And the vertex, or the center of rotation, we know is that same distance away, and we know that each pre-image point and image point have the same angle of rotation. The direction of the rotation will also be the same. I don't think we really need to mention that, but these two things are going to be important when we actually go to do the construction. So when we go to construct this, let's say if we're starting with this and it's getting mapped to this triangle, so we're going in a counterclockwise rotation, we go from the center of rotation. We're first going to measure that angle. So let's say I want to take C and I want to rotate it 90 degrees. I'm going to measure that 90-degree angle. And then I have to make sure that the distance from the center to each point, each pre-image to image point is the same. So those are going to be the two things that we're going to do when we do these constructions. So let's go ahead and try the construction. So for this, you have all of your rules here. So let's go ahead and we're going to start with coming up with our angle of rotation first, so that we can then use the compass to measure the distance to make sure that the pre-image distance to that center is the same as the image distance. So if we look, it says that we're going to rotate 75 degrees counterclockwise. So counterclockwise is really going to the left here, so our figure should end up over here. Counterclockwise, opposite direction as the clock. And we have our center. Remember, there's three things you have to know: the angle, the direction, and where to go from. So the center of rotation is point P. So what we're going to do is we're going to start with, I'm going to just make it like a dotted line here. And we're going to connect any point from point P through any of these points that we want to start with. So let's say I start with point F. So from point P, I'm going to draw a ray going through point F. And I'm going to extend this pretty far because I'm going to have to, this is going to be my angle. So I'm going to have to use my protractor to be able to measure the 75-degree angle. So I'm going to go from here. I'm just adjusting this so it goes from point P. Ignore all these little arrows here. Those just happen to come up on me. So now I'm going to take my protractor. Now that I have my center, you're going to place your protractor so that the center is on point P, and you're going to turn the protractor so that it's straight on the ray that you just constructed. And then you're going to go 75 degrees. So I'm going to be using the inside numbers here. I'm going to go 75 degrees, and then, so that's going to be right here, and I'm going to mark a little slash. I'm going to move this out of the way, and then I'm going to take and I'm going to construct from point P through that slash. Now, this is a 75-degree angle, what I just constructed, because I just measured it. So that means point F was going to have to be over here somewhere because I had to move 75 degrees. So I'm going to just label this so that you know it's 75 degrees. And remember, the next property is that that distance from the center of rotation to each point has to be the same. So that's where the compass is going to come into play. So I'm going to take my compass and I'm going to measure from point P to F. And then I'm going to mark that distance, and then I'm going to copy that distance over here where I got 75 degrees. Move that out of the way. And this right here is going to be F prime. Make sure you're labeling these as we do them. So then I'm going to move on to another set of points here. So let's say I use E, and I'm going to rotate E. So that means I start over. I'm going to do the ray. So I'm going to do these in different colors here. So my ray from F through E. I'm going to take my protractor. I'm going to place the center on point P again. I'm going to turn the protractor so that it lines up with the ray. And I'm going to measure 75 degrees on it. So using the inside, I'm going to mark 75 degrees. Get that out of the way. Now I'm going to take and I'm going to draw in that ray. So from point P through where 75 degrees is. I'm not going to mark that, but that's 75 degrees. Now I'm going to take my compass, placing it on point P, the center. I'm going to measure all the way to E. So I measure to E, mark that with an arc, and then come over on the other ray of my 75-degree angle, mark that with an arc. Because that distance, remember, from the center of rotation to each point has to stay the same. So that is going to be point E. So E prime. Then I'm going to do, let's say I do point D next. So let's go ahead and you start with your ray. So start with the ray, draw a line through it, or draw a ray through. I'm going to make this a different color. Draw a ray through point D, starting at P. Take your protractor, and we're going to measure. So the center of the protractor goes on P. Adjust the bottom so that it lines up with the ray. find 75 degrees on here. So 75 will be right here. Get that out of the way. Draw your ray through there. So this blue angle is 75 degrees. You don't have to draw these dotted. You can draw them solid. That's totally fine. It doesn't really make a difference. Now from the center, I'm going to measure to point D. I'm going to draw an arc to represent I measured. Come up to the blue angle here. And then that's point D prime. So then you just keep repeating this process for all the points. So if you feel like you can figure out the rest on your own, you don't have to continue watching. You can pause the video and finish it up. When you're all done, you're just going to connect, and you should have an L shape that's turned 75 degrees. I'm going to keep going in case you need the guidance through it. Otherwise, go ahead and pause the video and then just check your final image to see if it matches. So I'm going to start with my ray going from point P through C, measuring with my protractor. .75 degrees. Moving that out of the way, drawing my ray through. And then using the compass next to measure to point C. So you can tell this gets really crowded with all your stuff because there were so many points. So color coding is definitely going to be helpful here. So this is going to be C prime. And then the last 2 points, so I'm measuring, we're drawing a ray. Let's see, I'll do this in green. Drawing a ray from P to B. Get my protractor. Lining that up. Get 75 degrees marked. Move that out of the way. And now we can draw the ray in. So there's my 75-degree angle. Now we just have to put point B the same distance away. So I go from the vertex all the way to point B. This looks like it's just gonna fit. So I'm just gonna have to shorten this a little. But your compass should go all the way. So mine's just gonna be a little bit shorter. So then it's gonna be point B right here. So this will be B prime. Last one here, draw my ray through A. So from the center through A, measure 75 degrees. So 75. Draw my ray. And then I just have to measure to point A, which again, my compass will not reach that entire distance. Draw my arc, go over here, draw the arc. And remember that these aren't going to line up perfectly because my line here didn't go through B. Yours should end up matching up nicely. It's just the computer compass doesn't go the full length it should. So now I have my L shape. So now I just have to connect the dots. So I'm going to connect them with this segment here. So I have A. If you look, it goes from A to F. So just follow the order of the original. So A to F. Then F goes to E. E went to D. Then D went to C. C goes to B. And then these connect. And yours should end up looking straight here. So you should end up looking like you have an L shape. Remember, mine got a little messed up because my compass didn't quite reach here. So it should be nice and perpendicular looking like the original. So there's your rotation of 75 degrees counterclockwise.